Second sound in superfluids. This is the topic of discussion in today's lecture. Second sound in superfluids. You know superfluids, you know sound, but what is second sound? You know first sound, that is known to you, known to me. First sound means normally the sound which is heard by your ears is the first sound. Okay, that is what? That is nothing but the propagation of pressure waves through the medium. Through the medium means through air or through water or through any liquid or through any gas. Okay, that is nothing but the propagation means movement. Okay, propagation of pressure waves through a medium, and that is known as sound, which is heard by your which is sensed by your ears, and which is known as sound, and that is actually the first sound. And here we are talking about second sound. What is this second sound? This is also wave, but this is not pressure wave, this is temperature wave. And you know that temperature and entropy are related to each other. Okay, so this is temperature wave, this is also called entropy wave because they are related to each other. Okay, temperature and entropy. So this is also propagation of wave, but this is not the propagation of sound wave or sorry to say, this is not the propagation of pressure wave, but this is the propagation of temperature wave. And other characteristics are same as sound. That is why this is called temperature wave or entropy wave or the second sound. Okay. The reason is that there is a similarity between the propagation of pressure wave and propagation of temperature wave. But this phenomenon you would observe only in case of superfluids. Or here the experiment was done using helium-4, and you know that helium-4 is nothing but a type of boson. Okay, so in case of when the temperature is lowered, okay, to nearly 0 Kelvin, actually the temperature was 2.17 Kelvin. 2.17, which is very close to absolute zero temperature or 0 Kelvin temperature. Okay, so at that experiment, helium-4 turned into a new state which is known as the fifth state of matter, and it becomes superfluid. And you know the superfluid means fluids having zero viscosity, means fluids having no viscosity. In that case, fluids can flow without any resistance to flow, means without any viscosity they can flow. Various properties are observed in case of superfluids, but here we are talking about only second sound. What is this special characteristic? You know that when heat propagates through a solid, there is a diffusion of heat when it is propagating through solid, and there is also a dissipation of heat to the surrounding. But in case of superfluids, when heat flows through the superfluid, in that case there is no dissipation of energy to the surrounding. That means there is no energy loss. Therefore, intensity of the wave remains constant throughout the flow domain. Yes, intensity is not reduced at any point of the flow domain because there is no energy dissipation or energy loss during the course of the flow of temperature wave. Okay, there is no dissipation. That means temperature oscillates about a fixed value in case of superfluids, which is also known as, in this case if it is helium-4, this is known as Bose-Einstein Condensate, that is known to you. Anyway, so why this is called second sound, means the word sound why has been used here? The reason is that there is a similarity between first sound and second sound. Means there is a similarity between pressure wave and temperature wave. That's why this is also known as sound, but second sound, to distinguish it from the first sound, which is known as only sound, which is sensed by your ear, and that is called hearing. Hearing of the pressure sound, okay, hearing of the pressure wave or sensing of the pressure wave is known as hearing, right? Sensing of the pressure wave by your ears is known as the hearing action. But here, the second sound cannot be sensed by your ears. Okay, for this purpose, instruments, temperature measuring instruments are required. Okay, your ears are not able to sense this second sound. Anyway, so this was all about second sound in superfluids. Yes, this second sound phenomenon is observed only in case of superfluids, not for other fluids such as air or water at normal conditions. Okay, anyway, so this is the end of this video. Thank you for watching this video.